so that while I'm gone, you can still stay caught up with the other two classes from my even day class. All right, so today I'm going to talk a little bit about heterogeneous mixtures versus homogeneous or homogeneous mixtures. Specifically, we're going to address them in terms of a Venn diagram. So let me go ahead and start you off right here. So on the left-hand side here, we're going to write heterogeneous mixture. And then on the right-hand side, guys, we're going to write homogeneous mixture. So over here we got the homogeneous mixture, also known as a homogeneous mixture. So one versus the other. And of course in the middle here, we're going to put what is the same. So something that you guys probably recognize already and have thought about or thought through hopefully in class by now is that the heterogeneous mixture or heterogeneous mixture is a mixture that has visible parts. So has visible parts. Some very simple ones that you guys have probably dealt with before are things like pizza or cereal. But I'm just going to show you an example here of a heterogeneous or heterogeneous mixture. Very simple one, and I know you're having a hard time. I'm having a hard time with the camera here. Would just be a bunch of blocks of different colors mixed together in my hand. That was a mixture. Not anymore, so because I just tossed it. So that would be an example of heterogeneous mixtures. They can be not just solids, but of course they could be liquids as well. So some examples of heterogeneous mixture, you could say something like relish. You could say pizza, like I think I mentioned these already. You could say muddy water. So those are some common ones that you've probably come across at some point or other in your short lives. So what else did I have to say about the heterogeneous mixtures? Well, they can be separated just like all mixtures can be separated, and some very common ways of separating these mixtures, heterogeneous or heterogeneous mixtures, is through a process called filtration, which you've all done at some point or another. I know that you've filtered out spaghetti from water using the strainer. So they can be processed out through filtration. Another way that you guys may have not thought about before is magnetism. So magnetism is another way of separating these mixtures. Another way, the really simplest way, and the one that you've probably used on more occasions than not realizing it, would be picking. Not picking your nose, but picking the different parts out of the mixture as you go. So even if you have a whole bunch of socks, maybe your mom did your laundry for you, if you're lucky enough that she does that, and she throws you the bag with all the socks in it, she would tell you to sort or pick those socks apart. So that, I guess the more appropriate term for that kind of separation would be sorting, but I like to use the term picking because it brings up all kinds of images in people's heads. There's orifices that are picked at. Okay, so homogeneous mixture is different than the heterogeneous mixture in that it has no visible parts. So when you're dealing with the homogeneous mixture, you're dealing with a mixture that has no visible parts. You look at it and it looks the same completely throughout. Okay, and they're also known as they can be known as, in some instances they are solutions. So some solutions that you commonly deal with are things like salt water, tea, but not tea with lemon pieces or pulp, but just brown tea that you would buy in the container at the store, like a good Turkey Hill tea. I like Turkey Hill tea. Actually, my favorite Turkey Hill tea would be the half and half Turkey Hill. If you get a chance, get yourself the half and half lemonade iced tea from Turkey Hill with I think it's half the sugar too, or something like that. I find their iced tea and lemonades to be too sweet. But if you go with a half sugar and half iced tea lemonade, they're onto something with that. That's my favorite. All back to the topic again. Anyway, so solutions can be divided into two parts, right? There's the solvent part of the solution, and then there's the solute part of the solution. So each one of these parts plays a role in the formation of a homogeneous mixture. The solvent part, it does dissolving. So when you have this solvent, it's responsible for dissolving the solute. So this solute, it gets dissolved. So that solute breaks down. It breaks down in the presence of the solvent. So an example of a homogeneous mixture, which is also a solution, a liquid example, that would be the very common one, would be water with salt, right? Because you put the salt in the water and almost instantaneously you see the salt just start to disappear. Depending on how much salt you put in. The more salt you put in, the longer it takes for it to dissolve. In some instances, if you put enough of salt in there, the salt won't dissolve at all. That's when they call it, what you have is a saturated solution, when you can't get any more of this solute to dissolve into the solvent. So what we do in chemistry when we want that to happen, when we want to oversaturate a solution, is to add heat. Heat does a really good job of helping things dissolve. So that's a solution made of a solute and a solvent. And the solvent does the dissolving. And an example of a solvent could be water, and a solute gets dissolved. An example of that would be salt. So I'll just put a little example stamps on those two parts right there. So there's also some examples of a homogeneous mixture here. I'm going to show you this one. So when you look at this mixture right here, you literally see nothing. You would probably say that's water, and I would tell you to have a drink. No, I wouldn't, because I wouldn't want to kill you. It's hydrochloric acid, 2 molar, so that wouldn't do good in your stomach. But what you would think when you saw that was that this was just a simple glass of water, has no visible parts, when the reality of it is that it's got hydrochloric acid with water in it. And those two things together have made a solution. The water dissolved the hydrochloric acid, so the water was the solvent in this, and the hydrochloric acid, the HCl right there. I'm having a hard time pointing in the, no, wrong way. That way, the HCl in there was what got dissolved. So that was the solute. Another example, so I'll put this down here. So HCl solution. So that would be the water hydrochloric acid solution. So another one that we have over here, I'm grabbing it. I know I'm off screen now. Would be this. No, it's not for bashing people's heads in with. It's actually a piece of brass, and I'm sorry, not brass. Bronze, and bronze is actually a example of a solution. So bronze is made out of copper and tin. So what they do is they take they take copper, and they melt the copper down, and they take the tin and they melt the tin down, and then they combine the two together and they let it solidify in whatever shape they choose, and then they get a really sturdy, hard, relatively lightweight metal solution, homogeneous metal solution that you can use for weaponry. If you recall, if you have any history at all with any of the Greek philosophers or the Romans or anything, you'll know that during the Bronze Age was a big time where they used to make pretty much everything out of bronze: eating utensils, drinking utensils, weaponry, statues, idols, etc., etc., etc. And they were able to do some pretty amazing things with the solution that is bronze. Okay, so another one that I mentioned but don't have in front of me, guys, would be example would be salt water. So that could be another one. I could go on, but instead of me going on, we're going to do this for both of these now. So just pay attention, because I'm going to take you back over here for a second. Come up with two of your own. So these 1, 2 on your own here, and I want you to do the same thing over here. come up with 2 of your own over here. 1, 2 of your own over here as well, guys. And to mention, so the homogeneous mixture, you might think that the homogeneous mixture would be difficult to separate, but the reality of it is the homogeneous mixture is actually pretty easy to separate. You know, in comparison anyway to separating compounds, for instance. Harder than the heterogeneous mixture to separate, but relatively easy to separate. So I'll give you 2 ways of separating a homogeneous mixture. One is distillation, and you know you've probably heard the term still before from the mountains of West Virginia, where they used to distill whiskey and other forms of hard alcohol, and they still do actually. And believe it or not, there's still people up there who use the method of distillation to remove, to the best of their abilities to purify alcohol for human consumption, which, by the way, making on your own and hard form is not making beer, but making hard alcohol. It's federally regulated. These people who do that up there are actually breaking federal law. But they still do it, and they still run the stuff through the process of distillation. They still run the alcohol around the mountains out there. And there's still federal agents wasting their time looking for these people who are just doing what they've been doing since time memoriam for those guys. So that's distillation. Another one that, crystallization. Crystallization is a process that uses, let's see if I can fit that. I hope you can see that one. Yeah, barely. Crystallization is a process that uses heat and evaporation to pull out a solute from a solvent. So, you know, in this case, we talked about solute and solvent. We dissolved the salt in the solvent. If I took that salt water and I put it in a container and then put heat to it, the water would boil. Water has a higher boiling point than does salt. Therefore, the water boils off and evaporates, and the salt remains at the bottom. And I'm left with my solute. So these are ways of separating mixtures. There's actually 7 that you're going to learn about today. I threw 4 up there, or 5 I think I put up there. Yeah, 5, including the picking or sorting method. So what's the same between these? They're both mixtures, right? Both of these types of mixtures are definitely mixtures. Another thing that's the same between them is that mixtures are impure. So there's no purity that you're going to find in these things. They're basically impure. They're dirty, so to speak, dirty mixtures. So what else can I say about them that's the same? They can be separated. So both types of mixtures can be separated. And each one, of course, each one is going to be made of 2 or more different pure substances, right? The mixture itself is impure because it's made of a bunch of pure things. So there are both mixtures. They're both impure. They can be separated, and they're made of 2 or more impurities. Made of 2 or more purities. I'm probably going to spell that wrong, but yeah. So separated and made of 2 or more. So that's what's the same between them. So guys, with this in mind, and your Venn diagram's done, I want you to keep in mind that what we're going to do is we're going to carry ourselves through from being able to tell the differences between the heterogeneous mixtures and homogeneous mixtures to learning how to separate those. So if I'm not here, then the guest teacher, whoever that might be, is going to pass out. Going to pass out this packet right here, and I don't know. Hopefully, you'll be able to see that. But first, it discusses the mixtures that we just talked about with the Venn diagram, and then moving forward from there, it shows you actually how simple and useful those different ways of separating mixtures are. And then when you get back to this page right here, there's 12 questions that need to be answered on a separate sheet of paper, which will be graded for accuracy once turned in. So by the end of class today, guys, if you could make sure you have this Venn diagram for me so I can check that and put that into gradebook, and then answer those 12 questions that the guest teacher or whoever passes out to you, all right?